In this video, we present our work on a soft skin for dexterous robotic hands, performed in the Soft Robotics Lab of ETH Zurich. Our soft skin provides ideal contact with a wide range of objects. Our sense of touch also enables us to manipulate without visual cues. Current humanoid hand platforms only mimic our kinematics, but rarely provide soft skins and tactile sensing. In our work, we developed a soft sensorized skin for the 5 robotic hand. Our main contributions are the following. We developed a method for fast prototyping and optimizing of a soft skin for our dexterous robotic hand, the 5 hand. We evaluate the skin through both quasi-static pulling tests and dynamic tests and show that it enhances grasp strength without limiting range of motion or speed. We then mount custom-made pressure sensors under the skin and show that we can utilize them in classifying objects through grasps. Our fast prototyping pipeline used multi-material 3D printing to optimize the parameters of our complex origami structure made of DragonSkin 10. After 11 iterations, we arrived to a design that does not buckle or limit joint motion. The final versions of our finger designs were cast together with a palm in 3D printed molds.
We tested the molded skin first through quasi-static pulling tests. Experimenting on 3 different surfaces, we concluded that for raw friction surfaces, our skin increases grip strength significantly. We also tested if our skin limits the hand's fast dynamics. We ran step and sinusoidal commands of different frequencies ranging from 0.5 Hz to 2.5 Hz and found that the artificial skin only reduces range of motion to a small degree and does not induce extra latency. Finally, we implemented tactile sensing by mounting 46 custom-made piezoresistive pressure sensors on the hand. We glued piezoresistive platelets with a diameter of 2 mm on flexible PCBs and added a silicone dome-like tip on the top of the sensors. The sensor resistance was characterized in pressing tests with increasing forces and cyclic loading. The sensors were then taped on the robotic hand and covered with the glove. Using tSNE clustering, these sensors allowed the hand to distinguish between different positions and grasp objects. We thank you for watching.